Welcome back, Focus Learners. Let's jump right into today's explainer. We're taking a massive deep dive into the Adept Architecture. If you've been tracking Adept's evolution, you already know we are looking at a huge leap forward here. We're talking about a complete transformation from a passive knowledge system into a highly proactive, sovereign action engine. Okay, let's look at the philosophy driving this whole thing. The massive shift here is moving away from that era where you just ask a machine a question and kind of sit there passively waiting for a text response. Instead, the user becomes an active node in a sovereign network. You're actually directing local intelligence to physically execute workflows. It's a total game changer. Real quick, here's our roadmap for today. We're going from knowledge to action, checking out the anatomy of an agent, translating intent with AWL, the RITA actor ecosystem, multimodal vision, and finally, sovereign memory and security. All right, let's get into it. Section 1, from knowledge to action. This is the big pivot, moving away from just answering static queries to actually orchestrating dynamic physical workflows right there on your local machine. So the absolutely crucial point here is how Adept is defining an AI agent. They do it with extreme technical precision. Look, out in the wild, people slap the word agent onto almost any basic chatbot with a simple API plugin. Adept entirely separates itself from that noise. For them, an agent is software strictly bound by 3 pillars. First, intent. It needs to understand what you actually want, way beyond just your literal keystrokes. Second, action, the operational muscle to perform digital tasks, not just generate text about them. And third, autonomy, the capacity to plan and execute multi-step workflows without you needing to constantly hold its hand. Moving on to Section 2, the anatomy of an agent. Let's pop the hood and examine exactly how these agents are constructed within the system. And this brilliantly illustrates what's going on underneath. The underlying Rust framework actively avoids what developers call the God agent anti-pattern. You know, that setup where one massive, super error-prone script tries to handle literally everything? Yeah, we don't want that. Instead, the system treats agents as totally isolated, specialized actors, meaning if one task fails, it absolutely won't bring down your entire workflow. Think of this exactly like a factory assembly line. You've got these highly specialized workers communicating flawlessly to tackle complex problems concurrently. You have the planner agent handling all the heavy LLM-powered reasoning and breaking down tasks. Then the Navigator agent parses the DOM, basically reading the underlying code of a web page to interact with user interfaces. The Executor agent jumps in to handle function calling and error logic. You've got the Verifier agent doing quality assurance, and finally, the memory agent, managing your long-term context via the knowledge fabric. The whole shebang works together seamlessly. Number 3, translating intent with AWL. So how do we actually get these agents to know what we want them to do? Well, we use the Adept Workflow Language, or AWL. This acts as the critical translation bridge between your human intent and the machine's actual execution. Notice the incredible flexibility you get here. AWL is a safe, deterministic subset of JavaScript. Now, as a developer or a user, you can choose to be highly specific. You can explicitly code a UI click, literally writing click submit. Or you can just delegate the whole thing using the autonomous node with the act function. You just write an email to the team and let the system figure out the rest. Now, what's really interesting here is the recursive planning loop tied to that act function. When the executor encounters this command, it kicks off a loop where the agent dynamically generates subgoals, selects actions, observes the results, and, get this, autonomously replans if the outcome doesn't match expectations. This isn't a hard-coded script. This is true autonomy encoded directly into the system's runtime. All right, Section 4, the RITA actor ecosystem. Let's transition over to the execution chassis. This is where the actual heavy lifting gets done. The Rust-based event-driven actor system, or RITA for short. These are essentially the pistons of our engine. The RITA system guarantees 3 absolute must-haves. First up, absolute isolation. Like we mentioned, a workflow failure won't crash your broader machine. Second, asynchronous multi-producer, multi-consumer, or MPMC channels. This allows for true hardware-level parallelism, so different agents can communicate via lock-free channels. And finally, strict state encapsulation. This guarantees that each agent only maintains its own distinct context. No messy overlap. Prepare to be totally amazed by the performance yields here. By compiling those declarative AWL intents directly into this Rust-based actor model, RITA achieves a staggering 88% latency reduction compared to traditional Python-based agent frameworks. We are literally talking about sub-5 millisecond overheads for core actions like clicking and typing. It is blisteringly fast because it entirely dodges those heavy serialization bottlenecks. Section 5, Multimodal Vision and Collaboration. Speed and structure are fantastic for sure, but to truly navigate our messy digital world, these agents also need eyes and the ability to collaborate. Using specialized vision capabilities, which are actually inspired by advanced multimodal architectures like Fuyu, the agent literally sees your screen. It dynamically resizes and normalizes the display state, extracts UI elements, and then maps semantic labels to clickable buttons without even needing the raw underlying HTML. So if you tell it to click the red warning badge in the top right, the system inherently understands that spatial relationship and the visual pattern to just execute the command. It's wild. Let's see how this builds together into a cohesive workflow. Imagine tracing one single user intent, something like research recent advances in quantum computing. We can watch it go completely through the multi-agent assembly line. First, the planner breaks the task down. Then, multiple navigators instantly spawn to search Archive and Google Scholar in parallel. Meanwhile, the verifier checks the academic quality, and the memory agent pulls in your past notes on quantum mechanics. Then the executor synthesizes the final report. Finally, the planner reviews it against your original prompt. Just imagine never having to manually compile a dozen browser tabs of research ever again. It is a massive acceleration of human productivity. Finally, Section 6, Sovereign Memory and Security. We absolutely must address the most critical question of all here. How do we give these autonomous agents this kind of deep memory and execution power while guaranteeing that your data remains completely sovereign? The answer lies right here, in how AWL interacts directly with the zero-copy knowledge fabric. Because it's zero-copy, your system doesn't waste time or risk security by duplicating and moving your data all over the place. It acts as your permanent local memory bank. It uses memory-mapped vectors to achieve lightning-fast semantic retrievals. And because it natively integrates with local models, absolutely zero external cloud dependencies are required. Your data literally never leaves your hardware perimeter. Now, because these tools act proactively on your behalf entirely within your own hardware, strict guardrails are enforced to guarantee you never lose control. Agent actions are heavily sandboxed with strictly limited OS privileges. For critical tasks, like, say, sending financial transactions, execution is completely blocked until you give human-in-the-loop approvals. Plus, everything is logged in an immutable audit trail, and strict resource limits ensure that some random infinite loop isn't going to melt your CPU. The bottom line is you always dictate the precise permission level. The RITA system backs a granular, tiered permissions model. You can restrict an agent to be just a read-only research assistant that only queries the fabric. Or, if you want, you can elevate it to a fully trusted workflow automator with full action privileges to execute shell commands and modify files. You remain the sovereign authority over your system's intelligence at all times. Which brings us to a final thought for today's explainer. We've seen exactly how Adept uses specialized Rust actors, deterministic AWL translations, and secure zero-copy memory to create an absolute local powerhouse. So here is the question. When your local machine can autonomously see, plan, and execute at this incredible level of efficiency and security, all without relying on the cloud, what tasks will you delegate first? Thanks for joining me on this deep dive, Focus Learners. Keep exploring, and I'll catch you in the next explainer.